And here we've got a slightly harder pair of equations to solve simultaneously. We can label up the equations again to begin with, and then think about whether we have the same number of x's or y's. And we've got 3y and 5y, so they're not the same. And here we've got minus 2x and we've got plus 4x, so they're not the same either. And that's a big problem. We need to have the same number of x's or y's so that when we add or subtract the equations together, either the x's or the y's disappear. How do we deal with that? Well, it's actually quite easy. What we can do is say, take equation 1 and just double it. Double every single term in it. So when we do that, equation 1 becomes 6y minus 4x equals 26. And I'm going to call that equation 3. And now we've got the same number of x's, 4x in both. Now I know one's a plus and one's a minus, and that's different to the last examples as well, but that's okay, because what we can do here is actually add the equations together. So in the last two questions we've subtracted our equations, but here we're going to add equations 2 and 3 together. And if we do that, then we first of all have 5y and 6y gives us 11y, and then in blue down the bottom, I'm just going to think about this, plus 4x plus minus 4x, well, that gives us nothing. That's why adding is a good thing to do here. When you've got a plus and a minus sign, you add. So we get nothing from adding 4x and minus 4x, which is good. And then finally, if we add together 7 and 26, we get 33. So 11y is 33. That's easy for us to solve. Again, the fact that we've eliminated the x's out of it this time means we can deal with this resultant equation. Y is going to be worth 3 if we divide by 11. And then we can substitute back into one of the equations. So I'm going to take equation 1. And we now know that 3y, which is worth 9, minus 2x is worth 13. And that means that minus 2x is worth 4. And so x is worth minus 2. And so x being minus 2 and y being 3 is our answer this time.